So, hello everyone. Today we will be starting a new series of dynamic programming. In this series, we are going to solve CSES problem set, which is really important for competitive programming journey. We start with first problem, dice combination, and let me read the problem statement. Your task is to count the number of ways to construct sum n by throwing a dice one or more times. Each throw produces an outcome between 1 and 6. Okay. So this is the example. If n is equals to 3, like we have to count the number of ways to make the sum equal to 3. There are 4 ways. 1 plus 1 plus 1, 1 plus 2, and 2 plus 1, and 3. Okay. So I hope the problem statement is clear to everyone. Now we can directly move to the solution. So in order to solve the problem, uh, first we have to define the states of the dp. dp of I represents the total number of ways to make the sum equal to I. So for sum to make the sum equal to I, we have 6 options because dice has 6 configuration from 1 to 6. Okay, so I is equals to 1, 2, 3, 4, and 5, and 6. To make the sum equal to I, we have 6 options, right? So to do so, we run two for loops. First, it will go from 2 to n, and second loop will go from 1 to 6. Okay. So I will try to understand the whole thing. Okay, so let's see what is the transition dp of I plus dp of I minus j. Basically I represents the number of ways to make the sum equal to I, and this is just ending up. Okay, so j represents from 1 to 6. J is equals to 1 to 6 because I can make I via via first, second, third, 4, 5, and 6. It will be much better if I understand with code. Okay, if I explain with code. So what would be my final answer? Final answer is stored in dp of n. dp of n basically the number of ways to make the sum equal to n. Okay, so I will show you my code, it will be much better. Okay, so here is my code. So I will take the input n and I will declare a dp vector which will store my number of ways. So dp of 0 is equals to 1 and dp of 1 is equals to 1 because to make the sum equal to 0, the number of ways is 1. It means to do nothing, right? Okay, so dp of 1 is equals to 1. Why is it is 1? Because to make the sum equal to 1, we have only one option, right? Okay, so then I will run a two for loops which outer loop run from 2 to n. Okay, 2 to n, which basically represents I can make 2 sum, 3 sum, 4 sum, 5 sum up till n sum. Okay, so to make the sum equal to 3, we have 6 options, right? To make the sum equal to 4, we have 6 options. To make the sum equal to 5, we have 6 options. Okay, so I will run an inner loop from 1 to 6, which represents j. Okay, so in 6 options, I can select just a second, 1, 2, 3, 4, 5, 6. Suppose my ith index is 3. I can only select j if j is less than or equal to I. Okay. So to make the sum equal to 3, I cannot select 4, 5, 6. So I have to choose less than or equal to I. It means I have to select first, second, third to make the sum equal to 3. Yes, I think this much is clear to everyone. So the final answer is stored in dp of n. Yes, dp of I, dp of I plus I minus j, which is basically stored the number of ways. If j is less than or equal to I, then we can apply this operation. Yes, then we will print the our final answer. We can take the modulo because our constraint is higher. So yes, that's it guys. Thank you very much.